So we are ready to start chapter 12, and we're going to skip straight to section 12.2, which is on simple alkanes. Alkane is one of those functional groups that you learned about in chapter 11. Remember, I said it is the most boring of all the functional groups. An alkane is a molecule that has only carbons and hydrogens, and it has only single bonds. So no double bonds, no triple bonds, and no atoms other than carbons and hydrogens. So for example, just draw a really simple alkane, something little. Just 2 carbons, and each carbon has 3 hydrogens. Only carbons and hydrogens, and only single bonds. So that's nice and simple. Sometimes alkanes are arranged instead of in a straight line, they're arranged in like a ring or a circle, and we call those cyclo alkanes. So a cyclo alkane is going to be an alkane that has its carbon atoms arranged in what we call a ring. I know the word ring makes it sound like it's going to be a circle, because that's the shape of a ring, but it's not always a cyclic, like circle shape. So here is an example of a cycloalkane that's not a ring or a circle. The carbon atoms are arranged, there's 3 of them, so they're arranged in like a triangle shape. They're each having 2 hydrogens. This is a cycloalkane because, again, all of the carbon atoms are connected to each other in this sort of a loop pattern instead of having a beginning and an end. So what I need you to do is know the names of the alkanes that have 1 to 10 carbon atoms. You don't need to memorize this. You can look it up. You have a nice table in your textbook that gives you the names of the alkanes with 1 to 10 carbon atoms. This is table 12.1, and in my version of the book, it's on page 412, so it's going to be somewhere in that area. And this table is handy because it organizes the alkanes in 3 different ways. 1, just with the number of carbon atoms. 2, with the molecular formula, and it's written in true molecular formula, so it's all condensed together. And then 3, it gives you the structure using condensed notation, so you can get a better idea of how they're arranged. And then over here at the end, we have the names of all of these. So let's say, let's look at like 6 carbons. If we have 6 carbons, and the molecular formula is going to be C6H14, and here is the condensed structure of that molecule. That molecule's name is hexane. I'm going to pronounce all of these for you so that you can hear what they sound like from top to bottom. This is methane, ethane, propane, like what you would use in your barbecue, butane, like a butane lighter, pentane, hexane, heptane, octane, like what you put in gas, nonane, and decane. And so again, I want you to be able to find this table or something similar to it and be able to use it to name alkanes. For cycloalkanes, they were not included on that table 12.1. To name a cycloalkane, all that you have to do is just add the prefix cyclo to the front of the name. And that just lets everybody know that it's a molecule with that ring or cyclic shape. So for example, when I drew a cycloalkane, I drew a cycloalkane that had 3 carbons. So let's say I gave you a 3-carbon molecule and I asked you, what's the name of this molecule right here? You had to figure out what its name was. What you would do is go to your table. That molecule that I just drew is a 3-carbon molecule, and if you find 3 carbons on this table and look across, you'll see that that molecule's name is propane. So we will call this guy propane. So now, if I drew this molecule and I asked you to name it, you wouldn't be able to find this molecule on table 12.2 because it's not there. But what instead you would do is ask yourself, how many carbons are there? This molecule has 3 carbons in it. So now you go back to table 12.2, you find the 3-carbon situation. 3 carbons, if they are all in a straight chain, is propane. But in this case, they're not all in a straight chain, they're in a ring. So this molecule's name is not propane, but cyclopropane. So that's pretty easy. Not all of our alkanes have their carbon atoms in a nice straight chain or a nice easy ring like those examples that we saw. We do have some alkanes that we call branched. A branched alkane is one that has, it's an alkane that has carbon atoms that are attached to what we call the skeleton. Let's see what that looks like. So what I'm going to do is I'm going to switch to line notation because I know you guys are ready for this. So I'm going to draw an alkane, and this is an alkane that has 1, 2, 3, 4, 5 carbons. So we could name it if we wanted to name it. We could go back to that table, look at that table. We could find our 5-carbon alkane. It's right there. 5 carbons, 5 carbons. It's pentane. Those 5 carbons that are in a row in this molecule, they are called the skeleton. So let's see, how are we going to do this? Let's go like this. That is our skeleton. 5-carbon skeleton. So a branched alkane is one that has carbons attached to the skeleton, like that. Well, that's only 1 carbon. We'll give it a couple carbons. So that, carbons attached to the skeleton, that is a branch. Here's another example of a branched alkane. So we have our skeleton, just the continuous chain of carbon atoms. And this time we have a few branches in a couple spots. Branch. We can also have branched cycloalkanes. So here, there's a branched, let's make it even more exciting. There's a branched cycloalkane. There is our skeleton. Our skeleton is the ring. And the carbon atoms that are attached are the branch. We're going to learn how to name branched alkanes, but not right now.